Hey everybody, Mr. Fritz here. We are going to be graphing this trig function, this sine curve, in this video. And there's a series of steps that I usually like to follow. We're going to take a look at what all of these values do to our function, and then we're going to plot it. So I like to kind of list my attributes of this function. And that's kind of given by, like I said, all these values that affect this curve. So the first thing I'm going to start off with is my a value. That's this one right here. That a value gives me what the amplitude of my curve is. The amplitude of my sine function is 3. So basically what that means is the height between the midline to the highest point is going to be 3 units, and from the midline to the lowest point, that's going to also be 3 units. Next thing up is, that's one item. Next thing I like to look at is what this -1 on the outside does. That's going to affect my midline. My midline is going to be y equals whatever this number is. So y equals -1 is my midline. I like to take care of the y value changes first, the vertical transformations. I like to kind of group those together. And now let's take a look at the horizontal transformations. See, the first thing I'm going to look at here is, let's talk about the period. If I have a b value, as I do here, that's going to change my period to the function. And the period is always going to be 2 pi over my b value, or in this case, 2 pi over 3. So that means it's going to take 2 pi radians to complete one full cycle, one full wave of this sine curve. Next, the last function, or the last value we can consider, is this c value, and that's going to tell me what my phase shift is. The phase shift is going to actually use the c value and the b value together. So remember, that's equal to the c over the b, and with the c, we're always taking like the opposite of what this value is. So that's going to be a negative pi over 2 is my c value, and then divided by 3. If I divide these two things out, I get negative pi over 6. So that means that I've taken my sine curve and I've shifted it to the left by pi over 6 radians. So it's kind of like I'm normally starting at 0, 0, and this time I'm going to shift my x over by a pi over 6 to the left. The last thing I want to do is keep track of my key values, I like to call them, or the x intervals, the key x intervals. And basically I'm trying to calculate the spacing between each of my key values. Remember, the original sine curve starts at 0, and it goes up to 1, and then the middle, and then the min, and then the middle, and it looks something like this. And the spacing between each of these key values on the x-axis, the spacing right there, if I were to kind of chart this out, is pi over 2. That's the typical spacing between my key intervals. And that's the one full period length of 2 pi chopped up into quarters, which would be pi over 2. So my key x intervals, all that being said, I get my key x intervals by taking whatever my period is and dividing it by 4. Since I want 4 evenly spaced chunks in my x-axis. So the period is going to be, what did I say it was? 2 pi over 3. And if I cut that into 4, I'm going to cut 2 pi over 3 by 4, and that's going to be 2 pi over 12. Or, let's see, I'm going to get rid of this guy here. 2 pi over 12 is also known as just pi over 6. So that means that when I'm spacing out my x-axis, I should really stick with pi over 6 intervals. So why don't we start to build the axes up now that we have all this information. So for my x-axis, let's go in intervals of pi over 6. And so let's take a few tick marks out here to the right and a few tick marks out to the left. These are kind of evenly spaced. And so this is going to be pi over 6. This is going to be, so I'm just going to be adding pi over 6 with every tick mark. So let's make that 2 pi over 6, and then 3 pi over 6, and 4 pi over 6. I'm just adding pi over 6, 5 pi over 6. And in the other direction, I'll have negative pi over 6, and I'll have negative 2 pi over 6, negative 3 pi over 6, and negative 4 pi over 6. Now, if at this point you've caught that I can simplify a whole lot of these fractions, great, because we like to do that sort of a thing. So I'm going to take all of these reducible fractions and let's rewrite them using a nicer fraction. So 2 pi over 6, for example, that'll go away, and that will become pi over 3. 3 pi over 6, that will go away, that will become pi over 2. 4 pi over 6 becomes 2 pi over 3. And then I could do basically the same stuff on the negative side. So let's see. That's going to become a negative pi over 3. And then let's get rid of both of these here. So this one will be a negative pi over 2. And this will be a negative 2 pi over 3. All right, so those are my x key value points. And then for the y values, let's just think a little bit about this. My midline is negative 1. So right here, if that's negative 1, that's going to be where my midline is. My amplitude is going to go 3 above that and 3 below that. So I want to make sure I go down to at least negative 4 and go up to at least positive 2. And I'll go up one more just for, I don't know, for no good reason. Let's just keep going. All right, so let's draw out this midline. And I'm going to make a green midline here, and that's going to be y equals negative 1. So this is like the center line of my sine curve. And now when we graph this thing, so I kind of like took care of my midline. My amplitude of 3, that just really means I'm going to go as low as this and as high as this. So it's going to be kind of like my floor and my ceiling of the sine curve. And from here, I'm kind of ready to start graphing once I account for my phase shift. So I'm going to put these points here in. Let's go with blue. My shift is, normally remember I'm starting at 0, 0 with my sine curve, but I'm going to shift to the left pi over 6. And my 0 in the y has dropped down to negative 1 where my midline is. So now every pi over 6, I'm going to be moving along that original sine curve pattern where I go up, then the middle, then down, then middle. So I'm going to go up to positive 2. I'm going to go back down to the middle. I'm going to go down to negative 4. I'm going to go back up to negative 1. And really this is one full period here. And I can connect this. And there's my one full period of 2 pi over 3. Let's go one period in the left direction as well, just to complete this thing to get a good picture of it. So if I go to the left, I'm going to go down to start off, back up to the middle, and then up to the top here. And I can complete this picture to look something like this. So I missed that point a little bit, but you can get the picture. This is now 2 full periods of, oh, I should probably go one more. Let's see, this is going to be negative 5 pi over 6. And I should go back down to here. And so there you go, 2 full waves or 2 full periods, 2 full cycles of the sine curve. And really we just had to break it down into its minor components and then kind of put it all to a graph. So hope that was helpful.